Hello friends, welcome to my channel together with Abhi. In this module, we are going to talk about storage service, S3. So following are the topics we are going to cover. Okay, as you can see, first is file, block and object storage, buckets, S3 operations, data consistency, static website hosting, storage classes, object lifecycle management, some of the advanced features, and lastly, Amazon Glacier. So there are many kind of storage services provided by AWS. It is just not storage service S3, but there are multiple other services as well. These are based on different protocols. One is file-based, other block, and the third is object storage. S3 is object storage based service. So firstly, before moving ahead, we need to understand what are file, block, and object storage types. Okay, so let's get this started. Now, as you would know, when we talk about storage, it is just not a secondary storage. There is a primary storage also. What is a primary storage? This is RAM or ROM, okay, which is directly accessible by computer. You do not need any kind of input or output channels for accessing that. When we talk about secondary storage, it could be hard disk like HDD, SSD, things like that. Okay. And as you would know from the computer memory hierarchy, the things which are very close to computer like processor, registers, these are very fast, very expensive. They have small size and small capacity and they are volatile. What is mean by volatile is if you switch off the power, the memory is going to go away. But if you move down the pyramid, okay, even if you power off, it has a long-term sustainability of the memory or the storage. That's why these are called as non-volatile. These are large size, very large capacity, and very slow and affordable. So this is on a very high level, just to understand, just to give you a backup. So when we say computer, if in case it is able to directly access the storage, it is called as the primary memory. So I just wanted to establish a difference between memory and storage. Okay, you all would know about RAM and ROM. ROM is just a non-volatile primary storage used to boot the system using BIOS, and there are other secondary storage devices. Okay, now we are not going to study about multiple devices like HDD or SSD and things like that, optical disk. For us, it is just hard disk. We in this module we are just going to see what is the relation of the computer with the hard drive. It could be any hard drive, but what is the relation, how it is accessing it. So this is going to be our entire theory and we are going to talk about it. And what highest level abstraction do you have access to? Okay. So there are different models. We are just going to talk about the models right away. If in case you see how the computer relation with storage has evolved, firstly, the storage used to be inside the computer itself. And within the machine, within the chassis, the storage used to reside. But it had certain limitations, a lot of limitations actually, because your computer is the only point of failure. If in case your computer goes down, everything goes down, but very high speed and things like that. As the technology evolved, we were able to get this storage outside the computer machine, and we are able to even directly attach it, okay, using USB. But again, it had certain limitations and certain advantages to it. The third model which evolved is now that we are able to take this storage out and we can stack a lot of storage. We can have multiple hard drives stacked together as an array, and they can be made available over local area network, so even more than one computer can access it. So this is the third model. Okay, the fourth model is now, since the earlier model was over local area network, which is slow, why don't we have some optical fiber cables connected to each other so we can provide faster access to multiple computers. And since over local area network, we had to use a switch, and this could be a point of failure. If my router goes down, everything goes down. But in this case, we have some better things. So this is my this is my fourth model. And the last model is the distributed network, wherein a server based on a software distributes the entire storage over multiple storage nodes, and from there you can access it. So these are the basically the five models that we have, right? Now, what we are going to do is we are going to see what are the merits and demerits of these models based on few parameters. That is something we are going to study. So the parameters that we are going to discuss is firstly is the speed, how fast you can access data, scalable, how easily can it be increased based on the need. So in case tomorrow I require more storage, will I be able to scale it up or not? Mobility from different locations, if you are able to access it, is very mobile. If in case not mobile. How big a data it can handle will determine its volume. How capable it is to configure partitions and file systems is the configurability. Durable, how long lived the data can be based on the backups that you are taking, whether you are able to take multiple backups or not, it determines your durability. Availability, is it available if in case I want it right now? Is the storage available, or is it going to take like 5 minutes, 10 minutes, how much time? It is the availability. And the most important thing is level of abstraction. So there are three levels of abstraction. As you would know, everything that resides within the storage, the entire data is storage at a very basic level, which is block level. Okay. On top of it, we have file abstraction, and on further top of it, we have object abstraction. But these abstractions are very important, and why they are important is because addressability matters. Why it matters? Because we are able to judge two parameters. One is speed, the other is configurability. Okay. So how addressability, whether you are able to access the block, whether you are able to access file, or whether you are able to access object level abstraction, determines how fast you can access your storage and how configurable your storage is. Okay. Now block means just data, it just contains data. File, it contains data plus some fixed metadata, when this file was created, who created it, date of creation, and things like that. Object is data plus custom metadata. You can have some more key value pairs, some entire metadata, something like what is the purpose of this file and things like that. Now first understand the speed part of it. Okay. If you have the capability, if the computer has the capability of addressing or accessing the block, if in case you can access the block, how does the speed matter? Okay, so let's say you have a computer and these are all the blocks. You have an Excel file. This Excel file, when it has to be stored on a storage, it gets fragmented, it gets divided into 10 fragments. Each of the one fragment corresponds to one block. Okay, so your one Excel file gets divided into 10 fragments and distributed over 10 blocks. Okay. Now let's say tomorrow you make a change in column A of Excel file. Okay. And you know that this column A, this fragment of the Excel file resides on block number 1. So you have the capability of, if you have the capability of directly going and changing or addressing block 1, then it means it is going to be very fast, because you do not have to do any computation, any manipulation. You directly see, okay, I have to change block 1. You go there at block 1 and you change it. Now let's compare it to how file structure works. But working at a block level is not a very easy thing to do for a human. Okay, so what we did, we created some kind of abstractions. Okay, we created certain files, we created certain folders. So now if in case you make a change to your Excel file, which resides within a folder called as maths, okay, so firstly what you would need to do is, you would firstly need to find out the right folder, correct? Then you would need to find out the right file. There could be multiple files within that folder. You have to find the right file. And then from that file, you have to make a change to the right block. So there is additional steps that you have to do. Okay. That is why file abstraction is a bit slower than block level abstraction. So this is to establish that if in case any model which corresponds to block level access will be very high, very speedy, it is going to be have good speed. Now let's talk about object. Now what happens in object? Object is another level of abstraction. Okay. The important point to note about object is they are immutable. Why? Because the hash generation, the way of addressing an object is based on the content, a hash gets created. Okay. If in case you change the content, the address or the hash is going to change, right? So that means it is an immutable thing. An object is immutable. Tomorrow, if you in case you are going to change the object, it is the address is going to change. It is going to be a totally a new object for you. So that means if in case, let's take an analogy. If in case you have a car, okay, and if in case you just want to make a change to the steering wheel, so it doesn't allow you to just change the steering wheel. You will have to change the entire car. Okay. So here the car is an object, steering wheel is a block. If in case you had the capability of addressing at a block level, at a steering level, you would have just gone and changed the steering wheel. But because car is immutable, because object is immutable, you cannot just go and change steering wheel. You will have to change the entire car. I hope this clears your understanding of difference between block level, file level, and object level abstraction. Okay. Block level provides you highest speed and object level lowest speed. Block level provides you capability of configuration. Now, how configuration? Okay. So these are just a few excerpts from Wikipedia that I took to just help you explain that yes, there is an abstraction. Block is the lowest level, and above that we have file and object level abstraction. So you can go through these if in case you have time. Now let's come to configurability. What do you mean by configurability is your hard disk, it gets divided into partition, right? And each partition is consist of certain block size. Okay, so when you really reformat your system, it usually asks you for the block size, right? So what it means is hard disk get divided into partitions, and now if in case you have block level access, you can create each partition and access it using some file system, which different file system. Okay, obviously since I told you it is not easy to play with block level, that's why we again have some kind of abstraction, some kind of file systems to work with them. But if in case because of the block level access, you can configure different partitions with different file systems. So we can have ext2 for Linux, NTFS for Windows, another third partition with FAT, or fourth with ext3. So the essence is you want to access block, but you have different ways of accessing the block. So the configurability, the capability of configuration is in your hands. Okay, but again we are using it with the file system of my choice. So that is configurability. The whole thing is, I just wanted to establish that understanding for you. If in case you have the capability of accessing a storage at a block level, it is going to be highly fast and configurable. Okay, so block level access is good for operations wherein you have a lot of input output operations. You want quick data, such as a case of database management system, DBMS. Okay, you want quick data. However, object storage is good for things where you just want to write once but read multiple times, because object is immutable. You do not want to rewrite again and again, because it is going to change the object again and again. So it is good, object storage is good for things where you just want to write once but read multiple times. So now let's relate it to three storage types: network access storage, NAS, SAN, storage access network, and object storage. So network access storage is the third model that we had studied. In this, there is a device like this. You can see at the top right corner, there is a device which is we call as a NAS drive. Okay. Within this device, there are multiple hard drives that you can stack. Now, this device is going to store your data. but it provides file level access. So the technology which is involved with NAS drive, it allows you to have a file system, okay, a file level access. The file system that it provides is called NFS, Network File System. So you can just, if in case you are going to attach this NAS drive to some router of your home network, all the computers, all the devices which are connected to this router can see this NAS drive as a shared network drive on their system. All the computers can have access to this shared drive, whatever data is in it. But they will have file level abstraction. They would not have a block level abstraction here. Okay, they will not have a capability to access this drive at a block level. Okay, now because it is connected to Ethernet switch, okay, local area network, it uses TCP/IP UDP protocol. So it is just like an IP address, one IP address on the network. Okay, but if in case this router or switch goes down, everything goes for toss. No one will be able to access this network drive. Okay, so it has a single point of failure, but it can work only in a local area. It is slow but not very expensive. So friends, now let's talk about storage area network. In this, we do not have any device the way we had it in NAS. Rather, we have an array or stack of hard disks. These stack of hard disks are connected via optical fibers, via optical channels, so they are very fast. Okay, so if in case you connect your personal computer to storage area network, you would see just one hard disk associated on your computer. How these multiple hard disks are seen as one hard disk? It is the implementation of technology like RAID. Okay, now also this technology provides you the capability of accessing at a block level. Now, because you are able to access it at a block level, and because you see it as just one disk on your system, it allows partitioning and application of different file systems the way I have shown it earlier. The other thing is, here you can replicate your data across multiple stack of disk, right? So that's why it provides you better fault tolerance. If in case one stack goes down, the other stack can pick up the functionality for that. That is why, because of all this, because of optical fiber, because of block level access, fault tolerance, this is a very good mechanism of storage. It is very fast but expensive as well. Now the third model is object storage. Now you have to access it using internet. Okay, so what you do is, there is a machine, there is a server on which there is a software. This software tells that if in case I'm going to receive any data, any Excel file that I have received, I know how to distribute this file and send it across multiple storage nodes. Okay, so there are storage nodes which have these hard drives. This object is fragmented by the software, and it has the mechanism to address that object. So tomorrow, if in case you want to access the Excel file, you will again go back to the software. The software will have the mechanism to find out, okay, I have to get this fragment from storage node 1, the other fragment from storage node 2. I'm going to consolidate this data and provide the file to the end user. Okay, so the capability lies in the software. It is a fragmented system. Because it is over internet, you can access it all across the world. You can use simple REST API, but it exposes object level storage. Okay, this object level storage provides you with multiple capability because you can also write custom metadata. Okay, but these are immutable objects. When it means immutable, so you can just write it once but read it multiple times. If in case you are going to change this object, it is going to get replaced by a totally new object. Okay, so again, but this is very highly scalable because you can just keep on adding as many storage nodes as you want. It is available, it is durable because multiple data replication can happen, very economical. You can handle big data, you can make distributed systems like file systems like Google file system are there. So this is very highly scalable as well. but it is slow. So this is very best suited for scenarios like today, like Internet of Things and big data. So finally, we come to that five models that we represented. We are just going to compare them against the parameters. So inside computer, speed could be very high, configurable could be very good, but no other benefit you are going to get. Second is directly attached. Again, speed and configurable good, but no other benefit. Your machine is the point of failure. You cannot share it with anyone, so it is not scalable. The third is the important point. This is network access storage, and this is file-based abstraction. Okay, speed is going to be low because it is over local area network, which has network traffic. Mobility is low because it is over a local area. Volume, scalable, configurable, durable, available, it is not. So the purpose, the use case is totally different. Now, this is storage area network. The speed and configurable are good because it has block level abstraction. I already told you. Scalable, mobile, volume, durable, and available again are limited here. Okay. But let's talk about distributed network. This is an object-based storage, except not being highly configurable because everything is abstracted from us. It is everything. It has high scalability, mobility, volume, durable, and available. But in terms of speed, it is not that good. So I hope this has cleared your understanding, but still, if in case you have doubt, I have created a comparison sheet for you here where you can just go through all the things. So the same things again, but the most important thing to note down is SAN is block level. It is highly configurable. It is shown as a drive. It is shown as a hard disk on your system. Okay, so the best use case, because you can do a lot of input output operations. So wherever you need high input output operations, structured data is available, database management is available, DBMS is available. It is go for SAN. Okay, the corresponding technology in AWS is EBS, which we are going to study later. Now, if in case the use case is unstructured data, big data, file data, archive, where you have to just write once but read multiple times, object storage is the way to go. And this is S3. Amazon S3 provides object storage. It is available over REST API, HTTP, and you can do all the CRUD operations, but it is distributed network. For home related, where you home network, where you just want to share your data which is capped, and you do not want, like, you are not concerned about speed, you just want to see your data across multiple devices in a home network, you can go for NAS. And for this, the technology available within AWS is called EFS. So guys, I also came across a very good post from on OpenIO. I believe it is of good use to you, and it has a very good diagram which gives you a good understanding at a very high level everything that we have said, but you can just see it here. Block storage is more towards hardware level because it has block. Object storage is more towards software level, as we mentioned. And but different types of data, use of data, capacity, bandwidth, latency, and use cases is all very well captured in this diagram. So you can also refer this diagram, a good read. So that's all for today. I hope I've been able to help you out with understanding the basic concepts here. We'll get started for actual practical things in the next video. If you like my video, please like it, share it, comment if in case you have doubts, and do subscribe to my channel. Thank you.